Hello everyone, today we are going to see a topic called disk scheduling algorithm, which comes under the 5th unit. So moving on to the topic, the key responsibility of operating system is to use the hardware effectively. Similarly, the disk drivers have to meet this responsibility, entailing having a fastest access time and disk bandwidth. Let's see a physical representation of a hard disk, where a hard disk contains a series of disks or a bunch of CD structure which are collectively known as platters. In each platter there are n number of tracks, and each track has a division called sector. The actual data is stored in the sector. Now, to reach a sector, first we have to reach a track. To reach a track, we have to reach the surface of the platter. Then we have to reach the desired width. Now this is how we have to do this. Now to do this, we have an actuator arm which points to the particular platter, then to the track, then to the sector. Now the time taken for the disk arm to move to the particular desired sector, the overall time taken, we call it as a seek time. So speaking about the seek time is the time taken for the disk arm to move the head to the cylinder that containing the desired sector. For example, to reach this particular sector, we have to first select the first platter, then the particular track, and then go to the desired sector. Okay. Let's see a few examples of disk scheduling algorithms. Before that, there are 5 different types of disk scheduling algorithms. The first one is FCFS, the second one is SSTF, scan, C-scan and C-look. So let's see one after the other. Moving on to the first algorithm, FCFS scheduling algorithm. There is always a disk queue being maintained in the disk scheduling algorithm, where whatever request that comes from the processor to do an IO, either an IO read or a write on the cylinder, this queue, all the track numbers are being maintained in the disk queue. This queue is also known as a request queue, where it contains the track numbers which are requested by the processor. So according to our example, there are the track numbers are 98, 183, 37, 122, 14, 124, 65 and 67. Now it is already clearly mentioned that already the disk head is pointing at the cylinder number 53. So it's already in 53. The previous request was at cylinder 60. Okay. Prior to that, the cylinder was at 60. Now they are saying the initial request starting head was at 53, and previous to 53 it was at 60. Now our aim is to calculate the total distance of read and write head will traverse. So to do this, first let us look at the track numbers and assume that the total size of the disk is maybe from 0 to 200. So we have drawn as 0 to 199, and these are the track numbers which need to be addressed. So 14, 37, 53, 65, 67, 98, 122, 124, 183 and 199. As it's already clearly mentioned in the problem, the starting cylinder, the initial disk head position was at 53. So it is starts from 53. Then the next, since it's an FCFS algorithm, FCFS follows the requests that are addressed in the order they arrive in the disk queue. So whatever order they come, it's been addressed in the same order. So we have to go to the first thing as 98. So moving from 53 to 98, then from 98 to 183, then from 183 to 37, from 37 to 122, from 122 to 14, and to 14 to 124, and 124 to 65, and 65 to 67. This is how the actuator arm moves in the sector. So now our aim is to calculate the total distance of read and write head will traverse. So to calculate that, so we have to subtract the time distance. So 98 minus, let's take the first one, 98 minus 53, then 183 minus 98, and 183 Now we cannot, we have to take a larger number. So 183 minus 37, 122 minus 37, then 122 minus 14, 124 minus 14, and 124 minus 65, and 67 minus 65. So subtracting all these values, we will get 45 plus 85 plus 146 plus 85 plus 108 plus 110 plus 59 plus 2. Altogether, the total distance of read and write head will traverse is 640. That is, the seek time is 640. The overall seek time. So after FCFS, the next algorithm which you are going to solve is SSTF, shortest seek time first algorithm. The logic of SSTF is going to the cylinder number which is having the minimum distance. So each and we have to check which will be the minimum distance that could be next traversed. So let me take this previous example which was taken for FCFS. So the total block, the disk size would be 0 to 200. So 0 to 199, that is 200 cylinders, and the track numbers are arranged in the ascending order. So 0, 14, 37, 53, 65, 67, 98, 122, 124, 183 and 199. So here, as it's clearly mentioned in the problem that the disk head is initially at 53 and prior to the request was 60. So initial head of the rotating arm was at 53. So from 53, which should be the nearest or the minimum distance that could be traversed? You have two options, one is 65 and one is 37. From 53 to 65 would be the, obviously would be the minimum distance. So we are moving from 53 to 65. From 65, the nearest would be 67. And from 67, we have two options. Either we can go for 98 or 37. If we go for 98, it would be, distance would be 31, and it will go for 37, it will be 30. So we are choosing the next minimum distance as 37. So from 67, the rotating arm moves to 37. From 37, it moves to 14. And from 14, it moves to 98. From 98 to 122, from 122 to 124, and from 124 to 183. So this is how the SSTF algorithm works. The read-write head was initially at 53. Then from 53, we are searching which should be the shortest distance, minimum distance that could be traversed in the cylinder. So accordingly, we are traversing the cylinder numbers. So now to calculate the seek time, we are starting from 65 to 53, 67 to 65, 67 to 37, 37 to 14, 98 minus 14, 122 minus 14, 124 minus 122, 183 minus 24, 124. So obviously the subtracted values will be 12 plus 2 plus 30 plus 23 plus 84 plus 24 plus 2 plus 59. So the sum is going to be 236. So the overall seek time is 236. So the next disk scheduling algorithm which you are going to see is scan scheduling algorithm. The logic behind scan scheduling algorithm is that the disk arm starts at one end of the disk and moves towards the other end, servicing the request as it reaches each cylinder until it gets to the other end of the disk. So that's how the scan scheduling algorithm works. Starting from one end, moves to the other end. While moving, it's servicing all the cylinders that is on the way. So here also we are taking the same example as we took for the previous scheduling algorithms. So the total cylinders are 200, starting from 0 to 199, and the track numbers which are in the red disk queue are mentioned as above. The disk head initially starts at 53. Now here comes the previous request plays a vital role over here. So prior to 53, the cylinder was pointing at 60. So now to decide from which direction we have to move, this previous request plays a vital role. So before 53, it was previously served as 60. So the direction was in the decreasing order, 60 to 53. So now we have to move in the decreasing order. Suppose if it is from 50 to 53, then it would be in an increasing order. Now here it is going to be 60 to 53. So that means that the direction in which we are going to move is a decreasing order. So let's start the scan scheduling algorithm. as you know, we have arranged the numbers in the ascending order. The initial disk starting position was 53. So the arm needs to move in the decreasing order. So from 53 it has to move to 37, from 37 to 14, from 14 to 0. Until it reaches the other end of the disk, it has to move. So from 0 it has to move to the next in the forward direction, that is 65, then 67, then 98, 122, then 124 and 183. So it traverses back in the reverse order. So this is how a scan scheduling algorithm works. Starting this position, then finding out based on the previous request, we are finding out in which direction we need to move, and then we are traversing completely to the other end, and then again we are moving in the reverse direction. So this is how a scan scheduling algorithm works. To find the seek time, we are going to use the same formula. So 53 minus 37, 37 minus 14, 14 minus 0, then 65 minus 0, 67 minus 65, 98 minus 67, then 122 minus 98, 124 minus 122, and 183 minus 124. So the sum is equal to 16 plus 23 plus 14 plus 65 plus 2 plus 31 plus 24 plus 2 plus 15. So altogether the seek time is 236. This is how a scan scheduling algorithm works. And the scan scheduling algorithm is also known as an elevator algorithm, since because the disk arm behaves just like an elevator in the building. First serving all the requests going up, then reversing to the service request on the other way. So that's why it's called as a elevator algorithm. So the next algorithm in this scheduling is going to be C-scan scheduling algorithm. So it's nothing but a circular scan disk scheduling algorithm. The problem with the scan scheduling algorithm is when it was moving towards one direction, one end of the disk, and while returning back it serves the other. So once it's moving in one direction, the request in the other direction is being kept waiting for a longer duration of time. So that need to be solved in C-scan. So to do that, in C-scan, equal waiting time or uniform waiting time is being assigned for all the tracks or all the cylinders. So how to do that is, for example, let us take the same problem which we have taken for all the previous disk scheduling algorithms. The initial cylinder starting head was 53 and the previous to that was 60. So now we are not going to consider the previous request. Since we are going to use a circular scan, it's going to use a clockwise direction. So the initial head position was 53, then it has to move to in a circular direction, so it will be moving to 65, then it moves to 67, then the next request was 98, moving on 122, 124, 183 and 199 until it reaches the other end. Now once it reaches the other end, the C-scan algorithms, without servicing any request in the return way, it immediately moves to the other end without servicing. Now this is the most important thing. While in the scan algorithm, while returning back, whichever is the request is being served on the way. But here in the C-scan algorithm, it traverses in one direction. Once it reaches the other end, without servicing any request, it moves to the other end, and again from the other end it's been servicing in the forward direction. So now once we reach 199, that is one end, we are immediately traversing back to the other end 0, and from 0 it will be moved to 14 and 37 again in the time for the request on the way. So this is how a C-scan algorithm works. Now finding out the seek time, 65 minus 53, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 122, 183 minus 124, 199 minus 183, then 14 minus 0, 37 minus 14. Where you can notice that 199 minus 0 is not considered when calculating the seek time, because there is nothing being served during this period. Just we are moving the arm from the one end to the other end. So the sum is equal to 12 plus 2 plus 31 plus 24 plus 2 plus 59 plus 16 plus 14 plus 23. So altogether the seek time is 183. So the next algorithm which we are going to see is C-look scheduling algorithms. As we discussed, the previous two algorithms, scan and C-scan algorithms, move the disk arm across the full width of the disk. That is between 199 and 0. It moves until the end. But in practice, neither the algorithms are implemented in this way. The most common practice of doing implementation work is the arm moves till the final request. Once it reaches the final request, it moves back and forth. So it will not reach the end of the disk in any way. So C-look algorithms follow the same principle which was followed in C-scan algorithms, but it will not reach the end of the disk. Instead, it will reach only up to the final request of the disk queue. So moving on to the same example, the disk is starting at 53 and it has to move in the circular direction. So it is moving to 65, 67, 98, 122, 124 and last is 183. Once it reaches the final request 183, instead of moving to 199, it will immediately move to the next direction, other end, and where the next request 14 and then 14 to 37. Here the difference between C-scan and C-look is the end of the disk is not reached. Instead only the final request is being served. Now here also the similar principle only, between 183 and 14 on the return way it is not serving any request. So the C-scan and C-look has the similar principle. The difference is that the end of it is not reaching the end of the disk. So to calculate the seek time, 65 minus 53, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 122, then 183 minus 124 and 37 minus 14. Here also you can notice that 183 minus 14 is not used because we are not serving any request in between. So the overall seek time is 12 plus 2 plus 31 plus 24 plus 2 plus 59 plus 23. So that's going to be 153. So today we have seen the different types of scheduling algorithms, which is FCFS, SSTF, scan, C-scan and C-look. Thank you.